Hi guys, welcome to S-TechMatrix. So today in this computer network series, we will be seeing network topology. Welcome back guys to S-TechMatrix.
Imagine that you are building a city. You wouldn't just throw house anywhere, right? You would plan roads, the intersection, and the highways to make sure traffic flow perfectly. So in the digital world, we do that. We do the exact same thing. We call it network topology. So this is the blueprint or the layout of how computers are physically connected and logically connected. Okay. So the design you choose determines your network speed, its cost, and most importantly, what happens when something goes wrong. So today we are going deep from the old school bus to unbreakable mesh. So I'm going to explain every major topology with a real world example you will never forget. Let's dive into it. Okay. So network topology, we have bus, star, ring, mesh, and tree and hybrid topology. So first, basically, network topology. So the arrangements of device, nodes, and their connections. So for an example, so the arrange this, this and this is these are the links and these are the nodes. So the arrangement of device and their connections in the computer network, this is called a network topology. So it's defining both the physical layout and the logical flow of data. So it acts as a blueprint for how data travels between a device like a computer switch and routers, impacting a network performance by increasing scalability, reliability, and throughput. So these are the basic things about network topology we need to know before starting network topology. So types of network topology. First, we will be seeing about bus topology. So bus topology. Let's start with it's a grandfather of networks, right? So bus topology. In this setup, every single device is connected to one main long cable known as backbone. So here, this is a backbone. So this is the backbone. So think of it like a main road in a small town where every house built right along that one street. So these are the computers, and this is the one main thing which we use for communication. So when a computer A, so this is computer A, sends a message. So it sends a message. Um, to the computer D. So let's assume that this is computer D. So the data travels through down the road. So it travels from here and it's it sends to the computer D. So through the road, it's travel through the road and checks every door along the way until it finds the right address. So until it finds the right address, it will check here and it will check here. If the address is not there, then it will go to the next one. So why do people use this? It's very cheap, very little cabling required, and it's simple. Just plug and play along the line. So the real life example is think of old TV or cable line in an apartment building. One cable line comes in, and every unit taps into it. Okay, so that was that we can take as a real world example. Uh, just a minute. So a red alert problem. But here's the catch: is if the main road gets a pothole or worse, gets cut, the entire city stops. So if any damages made in this main line, then the whole network topology stops. So if the backbone cable breaks, the whole network dies. So plug if everyone talks at once, you get a data collection, data collision, making the network painful slow. So the performance will get slow if we are trying to put more data. So this is why we don't find this as a this in the modern office anymore. So we are moving towards the next one phase, the whole network stops. So the performance decreases when we have more devices here. So the next we are coming into a mesh topology. So in mesh topology, every device, every device. So the mesh topology, the unbreakable web. For an example, if you see, if star topology is reliable, mesh topology is invincible. In a full mesh, every single device is connected to every other device. It's provide high reliability, no single point contact fail. If any, for an example, like in first topology, if this any cable fails, then whole thing will be getting it. If the system fails, then it's not an issue. Others all will it will work. Okay, in this mesh topology, this no issue with this one. So supports multiple data, extremely expensive due to many cables and complex in installation. So for this, the real-time example, think of a high-security military communication system for ATC, air traffic control, air traffic controller. Um, if a pilot needs to talk to a tower, they don't just have an ratio frequency, they have five backups. If one road is blocked, then they take another one. So the state in a network of n devices, the number of cable is required is n into n minus one. So these many cables we require here for n into n minus one. So cables for this one. Okay. So if you have 10 computers, you need 45 cables. So the pros cons of this is it is impossible to bring this network down easily. It is a self-healing, so we can't even imagine that we can easily bring it down. So the cons of this one is it's an insanely expensive and a nice map to wire up physically. This is why we usually use it for critical service, not every desktop in our office we use, not for every desktop. Okay. So after this mesh topology, we will be going into tree topology. So tree topology, this is like a corporate hierarchy. Um, just a minute. This is like a corporate hierarchy. So so here now let's go big. Tree topology is a combination of star and a bus. It's hierarchical. You have a main backbone cable, and from that trunk, several star network branch out. For this, if you see for a real life example, the main fiber line connecting all buildings, the branches each building like a library. For an example, if you take a college, there we can find a main fiber line, and the branches is like library, science department, arts department, computer department, and every department, each department has its own branch connections. So the individual computer labs inside those buildings. So in library we will be having some computer and computer science and science department will be having. So in those there will be each and every department will be having a lab. So the individual computer labs inside those are buildings. So so the combination of multiple star topologies organized in a hierarchical manner. So easy to expand by adding branches, commonly used in corporate networks. Backbone failure affects many branches. So here if any backbone failure comes, it affects many branches. So require more cable. So here the benefits is it's incredibly organized. You can manage the science department without touching the library's network. But the risk is if main backbone snaps, all the branches below it lost connections to the outside world. If main backbone gets failure, then all the branch will be getting affected. You should go for large and multi-story organizations. Okay. So this is the pros and cons and about the tree topology. Then next we will be going into star topology. So in star topology, we will be seeing so the modern king. Uh, so now we are talking about star topology, right? So this is the most popular layout used today. Every device has its own private cable that connects to the central hub or switch. So all devices connecting through a central switch are an hub. So most commonly used topology today. Okay. So easy to add or remove devices, high performance. Each device gets a separate connection. Then central switch is the single point of failure. Cost slightly higher due to switches and more cables. Okay. So if we see somewhat deep into it, then we can identify. So in here, the real life example is your home. Just we can take our home itself. So you are using the Wi-Fi router is the central of the star. Your phone, your laptop, and your smart TV are the point of the star. If your phone loses Wi-Fi, does your TV stops working? No, right? So this is the advantage of this one. Why it wins is a fault tolerance. If one cable breaks, only that one device goes offline. The rest of the network stays perfect. So scalability. Want to add new PCs? Just plug into it an empty port on the switch. That's it. Easy troubleshooting. If a PC can't connect, you know exactly which cable to check. So we can easily troubleshoot it. The only catch is the central switch is a single line, single point of failure. If the switch dies, the whole network dies. But since modern switches are very reliable, this is the golden standard of the office, golden standard for office and schools. Okay. So this will be costly on, and then next we will be going into ring topology. So in ring topology, the devices are connected in a circular loop, um, connected in a closed circular loop. Okay? Hmm. So the relay race, for next, if you see, we have a ring topology here. Each device has exactly two neighbors. The connection from continuous loop a circle of data. So data flows in a one directional. Data flows in a one directional or two if dual ranges. So no data collision may occur in this one. So easy to manage, predictable performance. Failure in one device breaks the entire ring. So adding or removing device is difficult. So if you see a real life example here, think of a relay race. To send data, a computer waits for a token, an empty digital frame. If I can assume it as empty digital frame, um, it puts its data in a token and passes it to the next runner. So the data moves in one direction until it reaches the destination. So the pros of this one is no collision because only the computer with the token can speak. There is no shouting over each other. Performance, it handles high traffic better than the bus.
So the weakness of this is the biggest flaw. It is a chain. If one person in the relay race trips and fails, the baton never reaches the finish line. One break in a cable equal to total network shutdown. Also, if you want to add a new computer, you have to literally cut the ring and stop the network to plug in it. Okay. So next we will be so this is about ring topology, and then next we will be going to hybrid network topology. So in the real world solution, if you are finally if you see, um, we have the hybrid topology. In real world, big companies like Google, Amazon, just so hybrid topology. So So the real world solution, this one is finally we have hybrid solution. In real world, big companies like Google, Amazon, and don't just pick one; they mix them. A hybrid topology is simply a combination of one, two, or more topology. For an example, like maybe bus plus star plus red. So this with this combination, the hybrid topology now we are using. Imagine that ima- imagine that where a company, the marketing team uses a star topology. So imagine in a company we have marketing team. So here they use star. Let's assume that it's here. This one uses a star topology, and then next the server room uses mesh topology, server mesh topology, and they all are connected using bus. So this two is connected using bus topology. Okay, so this is the backbone. So this is the backbone. So why we use it? Because it's flexible. It allows company to grow and change based on each department needs. So if a marketing department needs some other topology, then they can change it, and they can customize it as per their needs. So this allows the company to grow. So it's more complex to manage, but it's how the actual internet is built. Okay. So hybrid is a combination of two or more. So the summary, if you see, so bus topology, if you take, so if you see, if you take bus, it's cheap. If cable break, entire network fails. Entire network fails. Then next coming into ring topology. So ring topology, no collision, no collision will happen because everything will flow in a one directional one. One failure breaks the loop. One failure breaks the loop. Okay, then the next one is star topology. So this one will be most reliable one. Hub is a single point of failure. So in star hub will be the single point of failure. Single point of failure. So the next it will be see tree. So tree is scalable. Backbone is a bottleneck. Backbone is a bottleneck. Then, but not least hybrid. So hybrid is more flexi but complex to design. Complex to design. So these are the thing. These are the summary of this video. So, which one is best? If you are a home user, star is your winner. If you are a data center, mesh is the way you choose to go. If you are a massive corporations, then you are living in a hybrid world. So based on the need, it changes. Each topology changes. So and that the network topology is explained. I hope this helps you ace your exams or design your next big project. So this is a basic video of this network topology. So if this video makes sense to you, hit the like button. It really helps the channel. Don't forget to subscribe to S-TechMatrix for more. Got question draw. If you have any doubts or comments, if you have any doubts, you can drop a comment.